My name is Tomas Zezula. I've been working as a software developer for too long and mostly on the backend side of things. And recently I've switched from Java to Kotlin, like in the last 3 years. And I've been quite amazed by the rich features Kotlin has to offer. So today I wanted to cherry pick one of the topics which speaks to me, and I've recently delved a bit deeper into it, and which is sealed classes in Kotlin. And I just wanted to show you how you can use them, and hopefully it improves the quality of your production code. So as Jirka hinted into, this community is supposed to be about communication, discussion, ideation. So the talks are intentionally kept short. So that's why mine has only 4 parts. After a short introduction where I will, show you or talk about like what sealed classes are, we switch to comparing implementation between Kotlin and Java. Then we talk about some basic house rules about constructors and how to initialize sealed classes. And then finally there'll be some attempt to show more real world example of how they could be used in practice. All right, so for starters, let's ask the question that's valid, I think. What problem do sealed classes and interfaces actually solve? Why should you bother? And there's this long definition, you can read it in Kotlin documentation. Basically it says, well, it's there to restrict the hierarchy of subtypes. So basically if you have a sealed class, all of its implementations are known at compile time. And that's a simple concept, but that's proved quite useful because essentially then when you know in advance what subtypes to expect, then you can use it for all sorts of things. In this presentation, I'll be talking about some sort of a result, success or failure, or other, you can model other predictable situation. And in that sense, sealed classes are not dissimilar from the concept of enums. Enums have been around for such a long time. We have used them even in C language. In Java, it's such a intuitive thing to have. But yet there is a distinct difference between sealed classes and enumerations or enums. Basically, enums are only set of constants. They cannot be instantiated. They are set in stone. They cannot carry contextual state. Whereas the sealed classes, you always create an instance which carries some context. So let me just show you an example. So I got this first example here where I'm comparing sealed classes and enumerations. I apologize. I hope that it's somewhat visible, even in the back row. So basically, I'm modeling result data type with enums, success and failure. And I do the same with sealed interface. And as you can see, it has 2 implementations, both of which are data classes. I'll talk about them later on. Success and failure. And immediately you can see they already carry some sort of information that might be useful. So if I do some bogus stuff with enums, I return either a success or a failure. But with sealed classes, I already when I get that result here, I already am able to access, contextual information. So I know something about that input, what exactly succeeded or what exactly failed. I can get additional information. So that's one major difference. And the other subtle thing I wanted to talk about is that the sealed classes, they lend themselves well to all kinds of mapping or validations. So here I model a validation result. It uses generics, so it can be used with any data type. Success carries the source type T as data, and then the failure just carries a reason why did it fail. And then in the validation method, I'm validating a customer entity. It could be an event from a Kafka queue or something like that, where Kotlin allows me to elegantly model some sort of validation rule. So the take if construct, basically what it does is I can apply it to an object. I know that this object cannot be null because in Kotlin I would have to specifically say it could be null, so it's not nullable. So I can immediately use it. Then if this condition inside holds true, then it returns that object back. And then because my success only takes a single argument, then I can use the double colon notation for succinct coding. And then if it's a failure, then at least I'm able to say, like, why did it fail? I can use some useful information extracted from the custom object, such as the ID. So that's, in a nutshell, the major difference between sealed classes and enums, which I'll show you in the next slide when it loads. Yeah. So basically, to wrap it up, enums are constants, subclasses are instances, they're objects, they can carry information. Now, obviously, Kotlin versus Java. So sealed classes are not a feature of Kotlin language. It's a generic, concept, and obviously it's been introduced in Java as well. So why not to use Java instead of Kotlin? And the reason is the adoption rate of newer versions of Java. So I think sealed classes were introduced in Java 15. This graph compares major releases of Java, so Java 7, which we don't need to worry about anymore, 8, 11, and 17. And as you can see, between 2020 and 2023, Java 8 was still kicking strong. Obviously, it dropped drastically, but it still takes quite a big chunk of the market. And then you can see that the replacement of Java 8 was in favor of Java 11, so that's like a logical next upgrade. So Java 11 still has decent share. And then if you look at Java 17, you can see like it made a huge progress since the last year, where the adoption rate overall was less than 1%. And it has risen sharply to over 9%. But in general, the adoption rate of modern version of Java is still low. So then in that case, unless you use it in Java 15 and above, you don't have access to sealed classes. And in that case, Kotlin can help you bridge that deficiency and, can be a good substitute. All right, so that's pretty much what I said. Yeah, the legacy still prevails. It's not a bad thing. It's just Java has been around for such a long time, so it's not easy always to upgrade to the latest version. Now, obviously, talking about differences between Java and Kotlin, I think example is the best way how to show it. So let me just switch into Java. This is someone else's. This is someone else's code. I took someone else's example, so I'm giving them credit. But basically, suppose that you've got sealed interface vehicle. In Java, you need to declare like the implementations. So immediately I can see that there are two subtypes of this interface, car and truck. And I declare both of them as so-called record types, which are essentially data classes in Java. And then I'm able to use them. So this is actually quite verbose to give Java full credit if we forget about this method for a bit. And then I don't even need these getters and setters because I'm using records. And then I would love to type something like main method, but I'm not in Kotlin, so this is not going to compile. I still need a class for this. So let me just create class application and then main in there. And then I can use, instead of declaring it like that, I can just use var type inference as of Java 11, I believe. And then I can simply access the properties directly. So the car object has a registration number field, and there is an implicit accessor for that field. I don't have to write Java beans, getters, and setters. So kudos to Java. I think this is a huge progress. Compared to Kotlin, in Kotlin, it's what you would expect. So you don't need to explicitly declare the subtypes, but you always, kind of have access to them. And then here, I can just declare the main class, and it's the same thing. And then if I want to access the properties of the data classes, I can do it directly. I can access these fields directly because they're constants. So that's essentially the difference, and I would say it's not much of a difference after all. Moving on, constructor and instantiation rules. So that's going to be a brief highlight, but I just wanted to make it clear, like sealed classes are abstract by their nature. You cannot instantiate them because the whole concept is, about you declare some sealed class and then you're supposed to deliver these subtypes that implement it so that you can pattern match on them in a one clause, for example. So it's an abstract class, going to be directly instantiated, and there is no public constructor. And then there is also this guarantee that no one else can just go and extend your classes at will. So for instance, if you have open source library where you use sealed classes and someone just uses that and then in their own code try to extend your sealed class to enrich it with some other subtype, that won't compile because there are some limitations. The subclasses must be in the same package, and the subclasses cannot be anonymous classes. So again, I can show an example. Let's start, with a simple example of, define a sealed class called myResult, and then if I try to instantiate that directly, it has a constructor, takes a string as a parameter. This won't work because the compiler tells me it's a sealed class, so it cannot be instantiated. That's fair enough. Now, this sealed class has two implementations, a data class, and then the other one, which is now abstract class. And this is legit because class failure is not sealed class itself, so it can be an abstract class, and obviously it can have its own implementations. So in this validate method, whatever I return as success is boring, but in the else clause on line 12, I'm returning an anonymous class, which is an instance of a failure. And that's okay, because failure is not a sealed class, so I can return an anonymous instance, but as far as the compiler is concerned, it's still a type of a failure. If I try to do the same with the actual sealed class, then again, the compiler tells me that can't be because this is a sealed class, so no anonymous classes are allowed. And when it comes to packaging, so note, like I have this package here, example 3, and then I have got a sub-package. And in the sub-package, I define some other implementation, and I attempt to extend from that sealed class, but that won't work because the restrictions around like locality. So I need to define it in the exact same package. So this is not going to compile. And now, lastly, when it comes to constructors, I just wanted to emphasize the difference between like nested classes and classes defined outside. Oftentimes in practice, we see that people define implementations directly inside of the sealed class or interface, and that makes a difference. Not only is it nicer, maybe it's nicer, but also it gives access to some private fields. For instance, this sealed class, HTTP error, has a private constructor now, which takes a status code. And if I have an object inside, then I can access that constructor and instantiate internal server error with the correct status code. But if I try to do this outside of it, like in this bad request data type, when I try to do the same, I obviously don't have access to the private constructor, and I can't use that. One practical note, if I go back to my simple example, I think it's easier to read. If I if I wanted to do it like this, nest classes inside, which is what I like to do personally, then that's fine, but now I have a problem with imports. Now I need to explicitly import the success class, even though I'm in the same package. So it's like cosmetics, but for the most part, but for yourself, you can decide whether you want to declare all the implementation within the sealed class itself and then deal with imports, or just leave it outside, and that's then easier to import. All right, so let me just revert that. Okay, and then moving on to the last part, which is also coding exercise. So in this so-called advanced example, I just wanted to show you how I've recently modeled or used sealed classes in a service layer. Let me actually explain the application a little bit. So if I go back to code, this last example is essentially a web application. It's using Ktor framework, and what it does, it's the typical API server that exposes some sort of user management API. There's an endpoint that allows me to get a user by the user ID, and then another endpoint which allows me to create a user, and both of which then return the success or failure, and then map it to HTTP response. Now, because typically we use things like web handlers or controllers, there's not much of a business logic in them. We typically offload that business logic to some sort of a service which deals with all the heavy lifting around getting data from a database or from external services and conducting all the calculations. So in the same manner, I have this user service which takes an instance of an HTTP client, and I use that on purpose because HTTP, in practice, your application is rarely isolated. You typically have to fetch data from external systems, and this is just to represent that. So if I go into that service, first what I notice is that the interface it offers is I wrap the result type, the return type into some sort of a result. So this tells me that the service doesn't throw exceptions or shouldn't throw exceptions, because if I just try to directly return a user, if I say get user by user ID, return me a user, well, that's a lie, because sometimes the user is not going to be found. I can improve it, just say, okay, maybe return a user if it's found, but there are other situations where there will be a myriad of other errors, and I won't be able to just represent them with a single Boolean flag. So that's why the service result data type kicks in, and it's quite useful. So here, basically, I'm just creating a generic result for any kind of a business logic, where the successful response then contains the data I expect, and the failure just tells me the reason and maybe a status code. So I use generics, I use covariance, because basically I don't want to expand on this concept. I think it's for some other talk, but basically this is telling me that I either return success with the expected type, or I return nothing and then some contextual data about the error. And then if I go back to the user service, it creates some bogus API link, which then it's like an external service it can use and call. And this is not supposed to fail, right? But there's no try-catch block here. And that's another thing that Kotlin excels at. It's like DSL, creating DSL. So this is essentially just a method that accepts a function as a parameter. And then whatever happens inside this block, it's safe to execute. This can fail, but then if I drill into the result of method, I can see just a huge try-catch block where I attempt to make that HTTP call. If I get a response, then based on the response status, I map it to either success or a failure, or I catch an exception and then wrap it automatically into a failure. Because I'm using Ktor, which uses coroutines implicitly, then this is a suspendable function, and Jirka will talk about coroutines in a little bit. But basically, I just need to catch an extra exception here, cancellation exception, not to break the structured concurrency contract. But that's again topic for some other day. And then in my routing layer in the web controller, I can just simply make the service call. I get the result back, and then I can easily reason about whether it's a success or a failure. So in case of a get endpoint, I resolve success and into HTTP 200, okay, and then return the data. Or I map a failure to whatever my API declares as a legit response status. So that's another point I wanted to make, that if you work with external services, you don't want to just bluntly return whatever is thrown back at you from them. You got your own contract. This is my own API. I probably have some swagger somewhere that declares like what exact response codes are supported. So I need to map them, accordingly. So for example, all these errors I'm mapping to a single unauthorized response, and so on and so forth. This is, by the way, an extension method. It's another feature of Kotlin. If this was Java, I would have to do something like this, and then add another parameter, say context. Then I would have to say context call, and then I would have to pass this reference into it. So this is like how I would code it in Java, but since I'm using Kotlin, I find like using extension method in this case is more appropriate and makes my code more concise. Again, like I could talk about Ktor, but I feel maybe not today. But basically this again is one large DSL that provides me with useful objects I can then use to build my routes and work with it. So that's pretty much it. Let's wrap it up for what I wanted to say today. I hope you found it useful, and if you want, now there's definitely space for questions, or we can chat after. Up to you. Thanks.
Tebe.
Jasně.
Na kameře.
Aha, super. Jak jsem malý.
Jaký to bylo?
Tak po dlouhé době nervozita, jasně.
První příspěvek na prvním meetupu, to je úplně boží.
Tak skvělý.
Ty jsi to fakt odpálil. Je něco, na co byste se chtěli zeptat? Co vám třeba zarezonovalo v hlavě? Co byste chtěli, nějakou otázku?
Já možná mám, kombinuješ přístup jako uncheck exception a těchto resultů, nebo to, co jsi jako ukazoval, že všechno končí nějakým failem, což typicky, ale jako s tím nic neuděláš, jo? Typicky nemám connection na nějaký server, co s tím asi tak můžu dělat, skončí to 500 nebo tak. A ve chvíli, jako tady jsi měl jednu jako vrstvu nějakou mapování, ve chvíli, kdy máš 15, tak je to fakt jako být prostý, ale furt to musíš přemlouvat jak blázen. Jestli jako, protože třeba u nás jako dáváme smysl ty resulty použít ve chvíli, kdy mám nějaký jako business case, jo? Třeba něco jsem nenašel, zkusím to někde jinde.
Ano.
Nebo nenašel jsem, založím to.
Jasně.
Jo, ale ve chvíli, kdy to je prostě nějaká jako exception, s kterou vím, že ani nic neudělám.
Ano. Na tohle dobrý příspěvek od Romana Alizarova. Nedávno jsem četl jeho blog a ten právě říká naopak, nechytejte exceptiony. Prostě nechte prostě ať vyletěj, a prostě je to prostě indikátor toho, že prostě něco je špatně, musíte jako vývojáři pak jako získat tu zkušenost prostě, až bude nějaká neohandlovaná exception, zamyslet se nad tím a možná přidat error handling, ale jak říkáš, v některých případech to třeba nedává smysl. Jo? Catchovat throwable možná není úplně nejlepší nápad. Lepší by bylo prostě mít víc specifické výjimky a na ty ostatní se vlastně vykašlat a prostě nechat je probublat ven. No, takže velmi dobrý point.
Dáme to smysl ty business casey, který jako aspoň z něco s nima můžeš udělat.
Ano. Já jsem vlastně udělal trochu záměrně, protože jsem to chtěl jakoby zdůraznit tu ideu, prostě, že fakt pracuji jenom success nebo failure, ale v praxi to samozřejmě tak jednoduché není. No. Děkuju.
Já myslím, že to taky spíš na Kotlin, že ten result object už je normálně definovaný v Kotlinu, tak jestli není nějaká napsaná věc, co by to dělala, co jsem vlastně měl napsaný, a bylo by to jako standardizované.
To je velmi dobrý nápad a vlastně v Ktoru to nevím, ještě jsem tak do hloubky úplně s ním nešel. Vím, že ten result v Kotlinu je obecně myšlen na nějaké jako frameworkové věci, jako spíš jako systémový, jako když potřebuješ vlastně vrátit výsledek nějaký jiný exceptiony nebo prostě něco takového, že nemá se to používat na nějaký jako business casey, tak záměrně ho z tohoto důvodu jako nepoužívám, ale máš pravdu, že v Ktoru třeba už může být něco nad tím, co třeba se nechá použít stejně, jako jsem tady ukázal já, ale v tuhle chvíli to nevím.
Já to taky nevím, tak se ptám, jestli...
Jasně, jo.
Bych se to tomu, jak tam bylo na ty slajdy na adopci.
Jasně.
Já nejsem javista, ale zajímalo mě, proč je tak pomalá adopce těch nových verzí.
Jo,
případně jestli víš, jak je to u Kotlinu.
No, takhle. Nevím, proč je tak pomalá adopce Javy. Já si myslím obecně, že je to technologie, která je tady spoustu let a ve velké firmě, je to prostě věc, která se používá hodně v enterprise, a ve velké firmě je přechod na novější verzi Javu často viděn jako riziková věc z řady důvodů, minimálně třeba effort přepisu knihoven nebo nějaký úpravy kódu, jenom prostě proto, že se zvedla verze Javy. Proto je to asi pomalejší. Já osobně aktuálně používám produkci 17 a nevím, no, nedokážu jako říct přesně proč je to ta adopce tak pomalá. Tohle je graf, který jsem ukradl New Relicku, tady jim dám kredit, takže klidně, tyhle slidy budou venku, tady je odkaz vlastně na ten zdroj a tam je poměrně dlouhý článek o tomhle, takže tam se možná dočteš jako ty důvody, ale já teďka z hlavy nevím. A u toho Kotlinu, tam si myslím, že ta adopce je trochu rychlejší a je to spíš jako pocitový, protože ten jazyk je novější a vyvíjí se tak nějak jako poučen z chyb právě v Javě. Takže vlastně ty nové změny v Kotlinu mi přijdou, že dávají jako většině lidí smysl. A já obecně třeba jako v tom si jako pocituji jako menší rizikovost, jo, přejít na novou verzi Kotlinu. Nezažil jsem, že by prostě byl nějaký větší průšvih s tím. Takže asi tak, no.
Díky za
Děkuju.
odpovědi. Taky, já tě ještě nepustím, ty jsi
nahrál poslední
otázka, ale už bude
dobře.
Jako poslední, že budete mít jako za chvilku přestávku a tak. Je něco, co bys doporučil? Zažil jsi nějaký praktický fuck up, jak se dneska oblíbeně říká? Něco, co by si řekl, na co dát bacha z technického pohledu, nebo případně možná nazdílej nějakou svou zkušenost, protože vím, že ty děláš dost jako ve firmách na projektech.
No, u těch sealed class vlastně, tam jste viděli vlastně pattern matching přes when klauzuly a vždycky tam je taková ta možnost jako else použít, prostě, že nemusím deklarovat všechny ty subtypy, ale můžu prostě říct else, co si. A to může vést k tomu, že pak třeba zapomenu jako ohandlovat nějaký důležitý stav. Takže lepší je, když to člověk, aspoň z mé zkušenosti lepší je prostě enumerovat to všechno. Když pak přidám nový subtyp, tak vlastně kompilátor mě zastaví a řekne, dobře, ale zapomněl si tady ten subtyp jako speciálně ještě ošetřit, tak rozhodni se co s tím a já pak můžu se rozhodnout, že řeknu, ale tak stejně else, anebo to prostě ošetřím. To je asi jedna věc. Jo, to je asi tak. A pak ještě ten pattern matching právě v tom whenu je zrádný v tom, jak je powerful, protože vlastně tam člověk může dělat spoustu věcí, může tam dávat conditiony, může tam prostě dávat různé podmínky a tak a pak se může jako stát, že člověku jako unikne nějaká důležitá podmínka a vlastně zareaguje ten kód špatně. No. Takže asi tak. V kontextu. Děkuji.